Last time we had left off with just a couple of more examples in section 4.4. The one that we had looked at before was this example number 7. We were turning from bases that weren't even base 10 into each other. So we started with a base 5 and we ended up at a base 7. And if you'll remember, when we did that, we had to do this intermediate step of a base 10. And we're going to do that anytime we're dealing with one base into another base, because it's a general process that works for any base conversion. So the one that we're going to take a look at next is going from base 2 into base 8. So again, just like before, if I'm going from 2 to 8, I'm going to go through base 10 because this process works in general. And again, if you'll remember, when I take any base into our base, base 10, I use multiplication. And anytime I move from base 10, our base, into another base, I use division. So just as a reminder for us, I'm going to mark those down. Now, taking a look at these and counting these out, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 numbers in this base 2 number, but I will start with with my subscript of 2. I'm sorry, my base of 2 with my superscript of a power of 0. Let me explain. So I have the numbers 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, and 1. And these are all in powers of 2 because this is base 2. So this is a base 2 number with a power of 0 to start with on the far right hand side. And we'll increase in our powers as we move left. So this is 2 to the 1. We have 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th, and 2 to the 10th. There were 11 numbers. Base 10 is the highest base, highest power of base 2 that I have. All right, so I'm going to multiply the value that is in the base times the value of that place value. So in that place right there, there is a 1, and in that place value, the value is actually the 2 to the 10th place. And then I'm going to have 1 times 2 to the 9th. I'll write this in even though I recognize that it is 0. This is 0 times 2 to the 8th. I have 1 times 2 to the 7th, 0 times 2 to the 6th, 1 times 2 to the 5th, 1 times 2 to the 4th, 1 times 2 cubed, 1 times 2 squared, I have 0 times 2 to the 1, and then 1 times 2 to the 0. All right, so we're going to add all of these up. You can use a calculator that will allow you to do this, or you can do this step by step. I'll do it step by step here just to remind you. So the first one is 2 to the 10th. That's 1024. The second one is 2 to the 9th, and that's 512. Now, you don't have to show this step, but you have to show either this step or the step before with all the powers of 2. One of the two have to be written out. In fact, let me draw a line in here just to make very clear that I'm doing a second step here. This one is a 0 because it's 2 to the 8th times 0. We have 2 to the 7th, which is 128. And then I have 2 to the 6th times 0. 2 to the 5th is 32. 2 to the 4th is 16. 2 to the 3rd is 8. 2 to the 2nd is 4. And then I have 2 to the 1st, but it's times 0, so that's 0. And then I have 1 at the end times 2 to the 0, which is 1, and so I have 1. So I'm going to add 1024 plus 512 plus 128 plus 32 plus 16 plus 8 plus 4 plus 1, and I get 1725. And while there's no need for you to do what I'm about to do, you can do this if it helps you to remember. This is in base 10, so it's understood to be a subscript of base 10 if I don't write this, but I'm going to write this just as a reminder to myself at this point that I'm not done. I'm right now in the middle. I'm right up here in base 10, and I'm supposed to be moving into base 8. So in order to move into base 8, I need to use some division, and in order to use the division, I need to figure out what I'm going to divide by. And because I'm in base 8, I'm going to divide by powers of 8. So the first power of 8 would be 1, and the second one would be 8. And then we'll do 8 squared, or 8 times 8, which is 64. And then I can multiply that by 8 to get 512. And I contend that that's big enough, because if you look at 512 and you look at 1725, it's going to go in about 3 times. and we're not going to be able to get it to go in any further. So 512 is big enough. If you try one larger, you'll see very quickly that it is unnecessary. So we're going to take the 1725 and we're going to divide by 512. It will go in 3 times, and that gives us, when we multiply 3 times 512, 1536. So we're going to take 1725 minus 1536 for a total of 189. And then we'll divide by the next power of 8, which is 64. 64 will go in twice. 2 times 64 is 128. So now I've got, and I've run out of space down here, but I have 189 minus 128 for a total of 61. So the next power of 8 is actually 8, and 8 would go into 64 7 times. 7 times 8 would be 56. 61 minus 56 would be my 5, and I'll divide by 1. I'll get a 5 here, and the remainder, of course, then is 0. So my solution, if you'll remember again, is located over here on the right-hand side of these, which is why it's so nice to work with this division scaffolding. So I have 3, 2, 7, 5, base 8. Now the other thing about this that's really nice with the 3257 or 3275 base 8 with all of this is that if you take a look at this, they and remember from last time too, the bigger the base, right? Base 10 is the largest base on this page right here. The smaller the value is next to it, 1725. And the smaller the base, the smallest base here is base 2 on this particular slide, the larger the value next to it. And of course the value next to it is quite long. So it's a good check step just to make sure you didn't sort of do things backwards. All right, one last problem is we're going to actually compare 3 numbers. And the best way to compare the numbers is to get them into the same base. It's kind of like when you try to compare fractions. Unless you just happen to know maybe the decimal representation, or if you can draw pictures, one easy way to compare fractions is get the same denominator, and then you can compare the numerators. So it's the same kind of an idea here. We're going to get the same base, and if we can get them all into the same base, we can compare the value next to that base. And the easiest base to get these to all match up in, of course, is base 10, because that's the one we're familiar with. So we're going to turn all of these from whatever base there's listed. So we've got a base 7, a base 4, and a base 11. And we're going to turn them into base 10. And to turn them into base 10, of course, we use multiplication. So these are 4 times some power. And then I've got 3 times some power. And since I'm working in base 7, I've got bases that are 7s. On the right-hand one, the right-hand-most side of whatever number we're working with, we have a power of 0. And then working our way left, we increase the power by 1 every time, so this is 7 to the 1. Now on this one, that works out really nicely. I've just got 4 times 7, which is 28, plus 3 times 1. Remember, anything with the 0 power is 1, so plus 3. This gives me a total of 31. And again, that's in base 10. You don't have to write it, but if you'd like to, you can, just as a reminder to yourself. All right, the next one is 1 times something, 3 times a value, and then 2 times the value. And these are base 4 because it says I've got a 4, so I've got base 4 in my expansion as well. Expanding in base 4, so I've got 4 to the 0, 4 to the 1, and 4 squared. All right, so 4 squared is 16. 3 times 4 is 12. And then 2 times 1 is 2, and this actually gives me a total of 30 in base 10. So although it looked larger, it's a 3-digit number even, compared to the 2-digit number on the very first one, 43, it's actually a smaller value once you can get them into the same base to compare them. All right, the last one is A2. If you remember, A is actually the number 10. We just don't have a numeral for 10, so we've called A the numeral 10. And then I'm going to multiply that by some value. And then I have 2. Now this is base 11, so I'm going to do base 11s in this expansion. This is 11 to the 0 on the far right and 11 to the 1. So the first one I actually really have 10 times 11, which would be 110. And then I have 2 times 1. Again, remember this is 1. This, oops, not that one. This one's 1. This one's 1. Anything to the 0 power is 1. So I've got 2 times 1, which is 2. So this is actually 112 base 10. Now, the directions say that we're going to write this in order from least to greatest. Now the least one, clearly for comparing base 10s, is the 30 base 10, but the point is to write it with the numerals we were given. So the numeral that corresponded to is 132 base 4. You could put a less than sign or a comma as to indicate we're doing the next one. The next largest was 31, or next smallest was 31 base 10. Whoops, got carried away. 31 base 10 written in the original form was actually 43 base 7. And then the largest value was A2 base 11. And that would be the correct order from least to greatest of those three particular numbers.